DJ active, let's do it.
Newton had 3 laws that we use in our everyday life. The first law was every object in motion will stay in motion unless acted upon by an outside force. And also, every object at rest will stay at rest unless acted upon by another outside force. So, you see this ping pong ball here. Do you think it'll move? Well, no, because nothing's acting on it except friction, so it'll stay there. But if I push it, it'll keep moving until it hits something over here.
Newton's second law states that the more mass an object has, the more force you'll need to push on that object to make it move. Here are 2 balls right here. One of them is the ping pong ball, one of them is the pool ball. Clearly, the pool ball has more mass. So now, I'm going to push them both together, and which one do you think is going to move more than the other one? Probably this one. It has less mass. This is an example of how the pool ball has more mass and more inertia than the ping pong ball. Therefore, when they collide, the ping pong ball flies backwards.
Isaac Newton's third law states that every action force has an equal and opposite reaction force. We're going to show this by using an exercise ball and an office chair. Here, we have a ball. It has a pretty good amount of mass, but it's mostly air. Over here, we have an office chair that's pretty heavy, and it has a lot of mass. So, for our experiment, we're showing how F equals ma, and how the force of this ball is going to collide with the chair, and they're going to exert equal forces on each other, and we're going to see what happens. So, as you saw, the ball hit the chair, and the chair moved backwards, but also the chair applied force on the ball and shot that backwards. Since the ball had less mass and more acceleration, it flew backwards, and the chair had more mass and less acceleration. So we use science every day, including in sports. So for example, in lacrosse, we use 2 types of circular motion. The first one is centrifugal. It's when the ball experiences inertia being pushed out of the head, so the ball flies outward. The other one is centripetal. That's when your hands pull towards the target that you're aiming at and your body twists. So actually, centrifugal isn't really a force because there's no object applying anything on it. But centripetal is your hands applying the force. So let's just see how they both go together.
Tell me when you're good, man.
Oh, it's good. When you move your body in the same way that you're trying to shoot, it creates more inertia, which creates more speed on your shot.
Newton's law of universal gravitation states that every point mass in the universe attracts every other point mass with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. As in, every object in the universe is attracted to each other, even when you do not feel it, which happens in most cases. These 2 things, do you think they're attracted to each other? Well, they actually are. Newton's law of universal gravitation states that every point mass will be attracted to every other one. Even though you can't see it and you can't notice it because the force is so small, it's there.
Well done.